So far, we have talked about thread and multi-threading a lot. Then you may wonder that, so how can we use multi-threading? And later you will have a multi-threading programming assignment to play with it. To use a thread or multi-threading, actually it is through thread library, which provides the programmer with an API for creating and managing threads. So from the designer's perspective, primarily there are two ways to implement the thread library. One way is that the library entirely is implemented in user space, so the kernel may not be aware the thread directly. Since all the threads are created in user level, so maybe you just use a many-to-one model to map all the user level threads into a single kernel thread. On the other hand, the other way is that the library is implemented on kernel level, which is supported by the operating system. So here, the one-to-one mapping may be used so that the kernel is aware about those threads and provide better concurrency or even parallelism with multiple cores or CPUs. And then there are three primary thread libraries. The first one is POSIX Pthreads. So this one can be implemented either on user level or kernel level. The second one is Windows Threads, which is implemented on kernel level. And the last one is Java Threads. So since Java Virtual Machine is supported by different operating systems, so it can be implemented either on user level or kernel level. So in this course, since we will use Linux programming environment, so we will further study POSIX Pthread library in this course. Pthreads is part of a POSIX standard API that is for thread creation and synchronization. However, Pthreads is just a specification, not implementation, which means it just describes the API or specify the behavior of a thread library, but the implementation is up to the development of library. So we may have different versions of a Pthreads implementation, but the Pthreads specification should be the same. And the Pthreads is commonly used in Unix operating systems such as Solaris, Linux, and Mac OS. Next, we are going to look at an example that how to use the Pthreads library to do a multi-threading programming. So for this simple task, we are going to calculate the summation of a given non-negative integer n in a separate thread. Later, after the separated thread finish the calculation, the main thread will print out the summation result on the screen. So in general, there are two strategies for creating threads. The first one is called asynchronous threading, such as the web server example we have discussed in the previous lectures. So in web server, there is a primary thread which keeps listening the request from the users. Whenever the request is received, a new thread will be created to respond to the request. However, the primary thread will keep listening the channel in order to serve the newly coming request. On the other hand, the other strategy is called synchronous threading, which is also called fork join. So you may still remember that. So when we talk about the process, we can use the fork function to create a new process. Then the parent process can wait the child process to finish, then continue the progress. Similarly, after the parent thread creates the child processes, the parent will wait those child processes to finish, then do the progress for itself. Here shows you the source code of this example. At the very beginning, since we need to use a pthread library in this program, we need to include the pthread.h header file. so that later we can call the pthread functions directly from this header file. Then we create a global variable sum to hold the final result. In order to use a pthread, you need to define a function called runner, and you have to exactly follow the format of this function, otherwise it cannot be used by pthread. For this function, it has to be a void pointer type function and accept only one parameter, which is the void pointer type. Within the main function or main thread, so you declare a variable TID to hold the pthread ID of the separate thread or child thread. So we also declare another variable attr, which is used to initialize set of thread attributes. Then we have two if statements to check the input parameters, which you passed from command line into this program. The first if statement checks whether you pass two parameters from the command line. One is the name of the program. The other one is a non-negative integer n. If not, the program will provide the instruction about how to use this program. The second if statement will use to make sure the input integer n is non-negative. Then we use a pthread attr init, this function, to initialize the attribute of the thread. It will get a set of thread attributes from attr and set them into the thread. Then we will create a new thread through pthread create function. And this pthread creation function will take 4 parameters. After the new thread has been created, the thread ID will be stored into TID. The second parameter is the thread attribute. And the third parameter is the function which will be used in the thread. And the last parameter is the parameter which will be required in runner function. So in this case, argv1 is the integer n. So we need to pass it into runner function. Later we will define the runner function. Then you will know that how can we use it. Then we have a pthread join function, which is very similar to the wait function in process. The main thread will wait the separate thread to join. And we use a thread ID, TID to specify that which thread will join into the main thread. So finally, the main thread will print out the final result sum on the screen. In the last part of this program, we will define the runner function. Within the runner function, first we create an integer variable I for the for loop, and another integer variable upper, which is used to hold the input parameter. Since the input parameter is a string type, so we need to convert it into an integer type through atoi function, which we have used previously in previous lectures. Then we need to initialize the global sum variable to 0. Here, since the thread within the same process, they naturally share the global data as we have mentioned in the previous lecture. We do not need extra communication between threads, which is much convenient than the process communication. Within the for loop, we will do the summation from 1 to the input integer n. Here we use the variable upper to hold it. After we finish the summation, the runner function will call pthread exit function to terminate the separate thread and go back to main thread. Then the main thread will print the final result of sum on the screen. So down below shows you the general definition of a pthread create, pthread join, and pthread exit, so that you can better understand those pthread functions. At last, and most importantly, we compiling the program. So beside the standard command gcc ucode.c, so you also need to add a dash lp thread into your command line, because pthread is not in the standard C library. So if you only type in gcc ucode.c, the compiler will complain that the pthread function has not been defined. So after you add a dash lp thread, the compiler will link the pthread library into your program. Then pthread functions will be found inside the pthread library and then compile your program without any problem. So since you already have the Linux environment in your computer, so you can test this source code in your computer and play with it to see what the result looks like. Then you may have a question that, so in the previous example, we only have a single separate thread. So can we create multiple threads? And when we want to join those multiple threads, so do we need to join them one by one? Surely that's not convenient. Yes, and certainly you can create multiple threads, and also you do not need to join them one by one. You can imagine that if you have thousands of threads, it can be disaster if you have to join them one by one. Pthread join allows you to do asynchronous threading on many threads, so you can do it through this way. You can use a thread ID array to hold the thread IDs, then use a for loop to create numbers of threads by this thread ID array, then use another for loop to join those threads with the thread ID array, just like we're showing here.